In our building we have two major forces to design. The first is your earthquake and second is your of wind. So if you're going to design any building, we have two lateral forces that we require to consider in our building design. Earthquake also and the wind also. So these two forces have the same nature, but it is having a different behavior. So same nature means it is having a lateral forces. So earthquake also will create a lateral forces in our building, and wind also will create a lateral forces in our building. But the behavior of the forces will be getting different. Earthquake will transfer the forces from bottom to top, and wind will transfer the forces from top to bottom. So if any earthquake strike to this building, then the path of the load distribution will be from bottom to top. So the load path of earthquake will be from bottom to top. So if earthquake strike, then it will transfer load from bottom to top. But when the wind strike to this structure, then the load path for wind will be top to bottom. So load will get transferred from top to bottom. So this is the major changes is there in between two of the forces. The nature is the same. These two of is having the lateral forces, but the load path, so how the load is going to transfer in this building is having different. When earthquake strike, the load will get transferred from bottom to top, but when the wind will strike, the load path will be from top to bottom. So this is the major changes is having between two of the load if you're going to consider in the case of the lateral forces. This is the important things that we have to keep it in our mind while designing the building, while taking the wind load and the earthquake. Now very important things I would like to tell you that this lecture series is all about the wind load. So we will talk about how to calculate the wind load, how to apply the wind load, how to look at the result in the wind load. So this lecture series will depend upon everything in the wind load only. Now move to the next slide, which is all about what is the wind load. So we will talk about much more about the wind load, but first of all we will study that what is wind load. So the answer of this is that wind load is a special kind of load on buildings, as it is capable of creating many types of the forces with varied effect based on height and shape of the buildings. The forces consist of shear, twisting, bending, and uniform loads. Now, what is the wind load is that wind load is a special kind of the forces which is acting on the building, and it is capable of creating a varied effect based upon the height and the shape of the building. So the forces will be created on the base of the height and what is the shape of the building. On the basis of that, the forces is going to be created, and the forces consist of shear, twisting, bending, and uniform loads. Now in this picture you can see that the wind load is applying to this particular building, and it is creating a forces, and this forces is based upon what is the height of the building and what is the shape of the building. And these forces is also consist of shear, twisting, bending, and uniform loads. Now you have understood that a wind load is nothing, it is type of the loads which is acting on the building, and this load is depend upon what is the height of the building and what is the shape of the building. And these forces consist of shear, twisting, bending, and uniform loads. So I think you are very clear about what is the wind load. Now move to the next slide, which is all about what is the effect on the structure. So what is the wind effect is going to create on the structure. Now we will study what is the wind effect on our structure. So any wind is applied on the structure, what could be the effect of it? So the wind effect are classified into two things. One is your static one and second is your dynamic one. So first of all, we will study about the static one. So static wind effect primarily causes elastic bending and twisting of the structures. So any wind effect which is causing the elastic bending and twisting of the structure, then we will call it that is the static effect of the wind on the structures. Now when any wind effect is causing the dynamic effect, the thing is going to change. The first was for the static one, which is causing only the elastic bending and twisting of the structures. Now question arises that which type of the structures will face the static wind effect. So the structure which is having a low rise building, medium rise building will have the static effect on the structures. But when we have a tall building, long span and slender structures, at that time the dynamic effect of the wind will come into the play. Now I think you're very clear about the static and the dynamic, right? So once again I'm going to explain you. The static wind effect will be causing the elastic bending and twisting of the structures, and it is applicable on the structures which is having a low rise or medium rise structures only. But the dynamic effect of the wind will be caused for the tall structures, long span, cylinder structures, where the dynamic analysis of the structure is essential to perform, and wind gusts causes fluctuating forces on the structures which induce large dynamic motions including oscillations also. So in the static one there was only causing the elastic bending and twisting of the structures, but for the dynamic one it is creating a large dynamic motions and which is creating the oscillations of the structures also. What is the oscillations means here? That let's suppose that I have one structure here and any forces is applied to these structures, it is going to move in this position. Again it will come its own original position. Again it is going to move here. Again it is coming back to these original positions. So this is the oscillations of the structures. So any forces which is creating oscillations in our building is called as dynamic effect of the building, and this is going to applicable for tall building, long span and cylinder structures like that. And for that type of the structures we are going to perform a gust factor analysis, or we can say a dynamic analysis for that building. So this is very interesting to see that how we can perform a gust factor analysis, or we can say a dynamic analysis to the building. So we will perform the static analysis also and the dynamic analysis also, and we will see that what is the major difference between two of the analysis which we are going to perform in our structures. In ETAP software we will perform the static analysis also, and also we will perform the dynamic analysis. So static analysis we will perform for the low rise building or the mid rise building, and dynamic analysis we will perform for the tall building and for the long building span and the cylinder structures. So dynamic analysis is generally we can call it as a gust factor analysis, where we will apply the gust factor in our building and we will look at the result. The static analysis also we will perform, and we will see that what is the result coming through the static analysis also. Now next is your that what is the effect of the wind load on the tall structures. So effect is getting to create a shear forces, moment and a deflection in our structures. So this is the major effect which is causing the wind load on the tall structures. Now move to the next slide. Now this slide is all about factor affecting the wind load. Now we have to understand that what are the factor which is responsible for the wind load on the structures. So actually the wind load depend upon, first is the wind speed, and also the wind speed will depend upon different cities. Let's suppose that if you're in the Bangalore, then we have a 33 meter per second a wind speed of that particular cities. If we are in the Mumbai, then we have a 44 meter per second wind speed in that particular cities. So this thing you will find in your IS-875 Part-3 code. So when you will open this code, you will find that what is the wind speed is specified for particular cities. So I'm going to open this code and I will show you that what all the wind speeds we have for particular cities. So let's move to that. So this is the code IS-875 part 3 2015, and when you will move to the page number 51, so here you will find here that for particular cities we have a wind speed. So for, let's suppose that for Bangalore we have wind speed of 33 meter per second, for Lucknow we have 47, for Mysore we have 33. So like that, for the different cities which you're designing, you see that what is the wind speed is there for particular cities or the towns. So this is the very important things that we have to know before starting the wind load design. Now let us move to the slide. Now we have understood that what is the wind speed and how we have to see the wind speed for particular cities. Now next is your terrain. What is terrain? Terrain generally means that what is the nearby situation of that place or the structure which is going to make on the piece of the land. To understand that, terrain has 4 categories: category 1, category 2, category 3 and category 4. So let's suppose that I have any piece of the land and here I need to construct any structure. So let's suppose that I need to construct any structure. This is the structure I need to construct it. Now nearby area, like surrounding, what is the situation there? Is there a lot of building is going to made? So already there are, if lot of building is already there in this structure, nearby structure, it means that the wind flow, there will be obstruction in the wind flow, and that's the reason this will come in the category 4. So this will come on the terrain category 4. Same situation I have another piece of the land where there is no surrounding building is constructed. So there is no any other building is constructed and the wind obstacle is nearly 0 here. So there is no any obstacles are there in this structure. When the flow of the wind will come, there is no any obstacle it is there in this structure. Then this will come in the terrain category 1. So like that, there are different terrain category, and on the basis of that we have to apply the wind load or we have to design the wind load. For better explanation, I am just opening another slide here and I am going to explain with this particular diagram here. So you can easily see that we have different terrain category here: terrain category 1, terrain category 2, terrain category 3 and terrain category 4. So you can see that in the terrain category 1 there is no building. It means that there will no any obstacle of the wind is there in this terrain category 1. When you see in the terrain category 2, you will find one building here. That means there is an obstacle of the wind but very less. When it comes to terrain category 3, you will find that few number of the building is constructed here. It means that there will be wind obstacle but very less. Now if you look at here that terrain category 4, generally in the cities you will find that terrain category 4 is there because a closely spaced building is there in these cities as constructed, and the obstacle of the wind is highly here. The flow of the wind is less because you will find that at, or we can say, as closed a space, there are a lot of building is constructed. So generally you will find this terrain category 4 in the cities. Now I think you are very clear that what is the terrain categories and how we have to categorize on the basis of the space it is available. So if there is no building or no any other construction is there, then it will come in terrain category 1. Very less amount of building is constructed, then terrain category 2. Few number of the building is constructed or structure is constructed, terrain category 3. And closely spaced if building is constructed in the cities, then that will come under the terrain category 4. So you can also look at the code also. So if you open the IS-875, if you open the code, you will find that there is a total 4 terrain categories: terrain category 1, then you will find terrain 2, category 2 3, and finally you will find terrain category 4 just below of it. So if you see here that you will find terrain category 4 here. Now the terrain categories are very important when you're designing the build, and you have to take the values while considering the design speed in your calculations. Now I'm coming back to the PPT here. Now next thing I will explain you, that is the topography of the locations. Topography of the location. Topography of the location generally means that what is the land configuration where the structure is going to made. Whether it is hilly areas, whether it is a plain area, whether it is a mountain area, whether it is a nearby sea areas. So what is the land configuration is there on that particular structures nearby. Now this is also very important because the wind speed is going to change basis of the topography areas. Where there is a hilly areas, then you will find that there is a high wind speed is there nearby it. Nearby sea areas also you will find that there is a high wind speed. So the wind speed is also depend upon what is the topography of the locations. So it's very important to know that what is the topography of the location. So if you open the code, you will find there are different categories also. If you look at the topography K3 factor here, and you will find that on the basis of this topography, you will find that wind speed is going to change, and it is very important to make it considerations of the topography factor also while calculating the wind speed, or if you're calculating the wind load. Now move to the next important thing, which is the force increase with the height. So what is happening here, that when you go increasing the height of the structure, you will find that the force of the wind is going to increase here. Because if you go into top of the floor, or if you're going to increase the height of the structure, you will find very less obstacles are there, and that's the reason why the wind speed will get increased. So it is written clearly that forces increases with the height. So it is very obvious thing is that when you're going to increase the height of the structure, or if you're going to increase the height of any building, the forces is going to increase and the wind load is going to change on the basis of this. Now the next factor on which the wind load is depend upon is the geometry and the exposed area. So geometry and exposed area generally means that what is the configuration of the structures you have, whether you have a cylinder structure, whether it is have a square structure, circle structures. So like that, what the geometry of the structure is, that on the basis of that also your wind load is depend upon. Also the exposed area, what is the exposed area of your structure, what is the width of the structure. Generally width is only the exposed area. So what is the exposed area, on the basis of also the wind load will get affected in your design. Now I think you're very aware about that, on the what basis, or we can say what is the factor which is going to affect on the wind load. Now move to the next slide, which is on that how the wind works. Generally means that what is the wind flow pattern, how actually wind is going to move. So as you already know that wind is going to move with the high pressure to the low pressure zone. So where there is a high pressure zone, let's suppose that here is a high pressure zone, then it is going to move into the low pressure zone. So there is always a difference of the pressure which creates the flow of the wind. So air flows from high pressure to the low pressure, and also the direction of the flow is influenced by the earth rotations. So how the earth is going to rotate, the flow of the direction is going to influence by this. So you have clearly understand that the wind works, how actually it is going to work high pressure zone to the low pressure zone. So where this high pressure zone, and if the low pressure zone is created, then wind will flow from high pressure to the low pressure zones, and its direction of the wind is influenced by the earth rotations. Now try to understand this with very simple example here, that let's suppose that this is the structure I have, building structure I have. here, from here the wind is going to flow. So this is the direction of the wind. Now if you look at that, this is the exposed area of the structure where the wind is going to affect it. So here the positive pressure will be created on the front wall, because this is the exposed area of the wind. Now if here the positive pressure is created in this front wall, then at the rear wall there will be a suction is created, and also suction will be created on the side wall also. Here also you will find that this suction will getting created. So if the positive pressure is created here, then negative pressure is created. So suction is nothing, it is negative pressure only. So this negative pressure is created on the rear wall, and the negative pressure is also created on the side wall also, and uplift of the roof is going to happen from top here. So if you look at here, this is the position where the uplift of the roof is going to create. Now this only we require to design it. Now same thing is explained here also. So this is the wind flow here, and the positive sign reflects that this is the positive pressure applied on this wall, and this is the negative pressure is applied on the rear wall, and also this is the negative pressure is applied and causing uplift here in this top of the roof here. So high pressure is created here, and the low pressure is created at this position. So this is only the wind works. This is the pattern of the wind, where actually we have to require to know that how actually the wind is going to work. Now this thing is going to help when you're going to analyze your project. So when you analyze the project, there only you will see that how the high pressure, where the low pressure is going to affect in your structures. At the analysis time, this concept is very much required to know it. Now I'm going to move with the next slide, which is somehow similar to this only. So this slide is also explained the same thing, that how the windward direction, leeward direction, how the high pressure is created and the low pressure is created. Now the same thing is explained in this particular diagram also. So if you look at this diagram, you will find that this is the elevation and the wind is applied in this direction. So here is the positive pressure created here. So I will call this is the positive pressure, and just rear of it, or we can say just opposite of it, there will be a negative pressure here. So I will call this is the negative pressure, and you can see that suction is created with this negative pressure, and same negative pressure is created at these positions also. So you can see that due to this negative pressure, there is a cause of uplift in the roof of this structure, and inside this there is internal pressure. So inside this structure there is internal pressure, where there is a wind is applied, that is the positive pressure. Just opposite of it there is a suction created, or we can say negative pressure, and at the roof level also there is a negative pressure, and due to this uplift is created to this structure. Now I think it is very clear that what actually this structure is showing you. Now move to the next diagram, which is similar to this only. So there is a little change here, that instead of this structure there is a building here. So when the wind is applied at this particular direction, then we can call it that this is the windward direction. From where the wind is applied, that part we can call it as windward direction, and just opposite of it, it is called as leeward direction. So if the wind is applied at this direction, then this is going to be as a windward direction, and this will become as a leeward direction. Okay, so this is very important to know that which is the windward direction and what is the leeward direction, because this thing is going to help when you are going to calculate the wind load. At the time of the wind load calculation, this windward direction and leeward direction will play an important role. Now I think you are very clear about this particular diagram. Now move to the next. This is the another diagram where showing the same thing, but it is showing in the plan view this, and this is showing in the elevation view. Now same thing like how the pressure was created in this particular diagram, the same thing here also. So wind is applied in this direction, the positive pressure is created, and due to this positive pressure, negative pressure is created at this position. This is the suction area, and here also negative pressure, and here is a negative pressure. Same thing in the elevation also, the same structure is shown in the elevations. This is the windward direction, positive pressure is created just rear of it and just opposite of it, negative pressure is created, that is suction, and this is the uplift it created in this top of the roof also. Now I think you are very clear about that, where is the negative pressure we created, where is the positive pressure we created, what is the windward direction and what is the leeward direction. Now I will move to the next slide, which is also very important slide, which tells you that in which project or in which structure you require a dynamic wind analysis to be get performed. Dynamic wind analysis means that in which project you are going to apply the gust factor. So this become very important. In the previous slide I told you that there is two effects of the wind. First is the static effect and second the dynamic effect. Now we will study that in which project you require to apply the dynamic effect of the wind. So the first thing, what is the first condition here, that height to the minimum lateral dimension, if it is greater than 5, then at that project you require to apply the dynamic wind. So let's suppose that I have a 45 meter as a height of my structure. So 45 I will write it here, and the minimum lateral dimensions of this structure I have a 5 meters. So I will take it a dimension of 5 meter. I will divide it 45 divided by 5, it is coming nearby 9. So 9 is greater than 5, definitely 9 is greater than 5. Then I require to apply a gust factor or dynamic effect of the wind in this particular structure. This is the first condition I have. Now what is the second condition is there? If the natural frequency in the first mode is less than 1 Hz, this is also very important. Try to understand here that if your natural frequency of your structure is lesser than 1 Hz, then you require to apply the gust factor. So how you will calculate the frequency? So frequency, if I want to calculate the frequency, I will denote frequency by f, then I have to divide 1 by time period. Okay, so what actually I required first, I required a time period to be calculated, and you can look at that fundamental time period is calculated by t is equal to 0.1 multiplied by number of the floor. N is the number of the floor. So this is just a judgmental formula to calculate time period. You can use this formula. So let's suppose that I have a structure of 30 floor. So I'm just counting this number of floor as a 30. Then how I will calculate the time period? Tp will be 0.1 multiplied by 30. So it will be 3 seconds, right? Now I told you how you have to calculate the frequency. Frequency is 1 by Tp. So 1 divided by 3, how much it is? So you can just calculate it, 1 divided by 3. So you can open the calculator. 1 divided by 3, it is coming 0.33. So the frequency is 0.33 Hertz. Now what is the condition here? That if natural frequency in the first mode is lesser than 1 Hertz, generally yes, it is less than 0.33 is lesser than 1 Hertz, then I require to apply the dynamic effect of the wind. So this is how you have to do the calculations when you have to find that in which structure you require to apply the wind load in the dynamic form, or we can say a gust factor if you require to apply it. Now we have come to the end of this lecture. In the upcoming lecture we will look at upon an ETABS. So we will see that how we can apply the wind load in our structure, and also we will see that what are the different methods through which we can apply the wind load in our ETABS. And after applying the wind load, we will do the analysis also, and also we will see results also, what is the effect of the wind load when it is applied to the structure. So these are the important things we are going to see in the upcoming lectures of the wind load. Thank you for watching. See you in the next lecture.